All right, so we've got this population parameter, rho, and we're going to estimate it by taking a sample, and we're going to estimate it by r. And of course, as always happens with parameters and samples and inference, etc., we're going to use this r to make inference about rho. And suppose we want to test the hypothesis about something about rho. I'll look at one particular one, because that's the only one that really works easily. And that is when rho is equal to 0. So the test of the hypothesis that they are uncorrelated, that x and y are uncorrelated, okay? So what we need is the sampling distribution of r when rho is equal to 0, and there it is. It's r divided by this thing. So it's almost like the t. It would be r minus 0, r minus rho, but rho is 0, so it's just r. And then so it's instead of 1 over n minus 1, it's 1 over n minus 2, and there's the variance. So the variance would be 1 minus r squared, all right? So there it is. That's our statistic, and we can apply this to test rho is equal to 0. So for example, in the DPT example that we looked at, the r was minus 0.829. So we can look at our t as minus 6.29, and we get that the p is less than 0.001. If we want to do it by hand, that's how you do it. You compare it to a t with n minus 2 degrees of freedom. All right? In this case, n minus 2 was 18. Student's t. You may have noticed that they actually calculated an r here of 0.791, and they put a p less than 0.0001 as the significance value for this one. If we go to the first 50 subjects in our Framingham heart study, and we test the hypothesis that the correlation is 0, the way we do it, the command is pwcore, and we get that the correlation is 0.7982, extremely high, and the p-value is underneath it, it's 0.40. Okay, so the p-value is less than 0.405.